Okay, we'll go ahead and get started. In yesterday's session, one of your classmates, and maybe it's someone that's already in here, maybe one of you two had mentioned, okay, that is there a practice paper over some of these carbohydrates and amino acids? And at that time I said, well, that's a good question. I really don't know. Because at that time, I was just explaining to your classmates that I was looking for something titled Chapter 22. Well, that's the organic portion. When we're talking about that of the carbohydrates and amino acids, that is more so biochemistry. Okay, so I actually have this. And you students went and grabbed a book like we had asked. But some of the content we're going to take from here because this is the organic and biochemistry book that the seniors would use. There's some overlap in this. So when we start talking about some of these compounds then, okay, so 710 is where organic chemistry had started. Okay, so it's not that that is old news, but it's something that we have covered in the past. Then if we were to turn the pages ahead, we eventually get to chapter 23 in here, which is entitled the biochemistry portion. And I think we looked at some of that on page 751, okay, because we probably talked about glucose, and they show fructose there. And I think we drew, was it maltose? I think we drew maltose, okay? So the important part of that is, okay, you have this book as a reference that we typically have with your, just says chemistry on there. But in here, and I don't know if you can see this, but all of these tables that you see on here, at least I call them tables, these are all the different types of monosaccharides you could discuss. Some of them are 3 carbons in length, some of them are 4 carbons in length, but what we have spent time on is 6 carbons in length, okay? So what we mean by that is, if you write this down, you probably don't have to because you might have this material already, okay? So 2 things that, well, I wouldn't say 2 things. One thing that we would want you to know from this is, that's why I still need one more. Okay, what would the major difference be between what you see between these two? And we wouldn't have to go any further. It's something that we had discussed. Then we could put these 3 lines in here. Okay, because this is kind of a trick question. What's the difference between these 2 sugars? And this is what we had talked about, okay? So where is this double bonded oxygen on this structure? On which carbon? The first one. Where's the double bonded carbon on, or excuse me, oxygen on this compound? So on the second one. That makes a big difference, okay? Because these are all categorized as what type of sugars? Starts with an A. No, not A. And I'm interpreting you're saying asymmetric, but that still would not be the case. Maybe we could look at something like this, and that might give you a little more of a clue. We got the same concept with these 2 compounds here, providing you can see them. I think, yeah, they're a little faint. They're red, but you get the idea. So what type of compound is this? I mean, you don't have to name what it is, but what organic family is that? It's the same as this one. Because where's this double bonded oxygen on which carbon? Okay. Where's the double bonded oxygen on this one? Okay. That's going to be a big difference between these 2 types of compounds. And those organic families we're talking about, this one starts with an A, this one starts with a K. Because we said this type of diet is maybe something you eliminate this type of sugar. Okay, so that must mean that this is a ketone, which it is because this double bond oxygen is not on the end or the first carbon, where this one is. So if this is a ketone, this is a ketose sugar then this must be what type of sugar? It starts with an A. What is closely resembling a ketone? I think you said it. Aldehyde. I think that's why I'm interpreting you said. Ketose sugar, aldose sugar. Okay? So then it's the differences where these OHs are bonded on here that gives you the different types of shapes. Okay? Because we had done this, it's probably in your notebook if we were to say, all right, we're going to draw glucose. And chances are you have this already. We would say it's right, left, right, and right. Okay? Because how these are oriented then is going to make a big difference on the way this structure is going to look. And that's why we have this as a reference, because in your book on page 752, all they show is glucose, okay, and fructose, which is also a type of ketose sugar. Then you put the two together, a monosaccharide and a monosaccharide, then you can make a disaccharide. That's what we call sucrose. We're not too concerned about that for right now, okay? But those aren't the only types of aldose sugars. I mean, like I said, look at all these that we could see in this table. These are all different types of aldose sugars that are called hexoses because they make a 6-carbon ring structure, where this one only makes a 5-carbon ring structure. Okay. Ketose, aldose sugar. Major difference. Is there anything else that you can see that is different between these two besides where the double bonded oxygen is? What is way down at the bottom of this compound? What do we see here? CH2OH. Okay, and what do we see here? CH2OH. So what do we see on carbon 1 then? Because it's an aldose sugar, so it's C double bonded oxygen with a hydrogen. But what do we see on this one then, on carbon 1? Yeah, it's the same as on the bottom. So two different ways that you know that this is a ketose sugar. One is right here, and two, that double bond oxygen is on the second carbon. So again, we have drawn this before. That's all old news. So what I want you to do, just listen to these following names. We've got allose, altrose, gulose, idose, or talose. Okay? Allose, altrose, gulose, idose, or talose. What one sounds cool? Talose, okay? So the reason that we're having you pick that is if we were going to talk about talose, okay, that means that we've got this following orientation, which is left, 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 and right. Okay? So now what we can do is use what you drew as, okay, I got to think about this. We've drawn glucose, and the other one we drew was mannose, I believe. Okay? Because when you put mannose together with glucose, well, then you make a specific disaccharide. If you put two glucose molecules together, you can make maltose. And if you put galactose with glucose, then you get lactose. So those are maybe some different types of monosaccharides and disaccharides that you have heard of. So what we want to do, okay, so we're going to draw this talose because that's what you had picked. Okay, So that's just an oxygen atom. And if we really wanted to be precise, or however you want to look at that, it's actually this oxygen atom right here, okay? Because now, and you can, again, you can be looking at page 752, and it's going to look very similar to that, because that's glucose. And then maybe what could look even more familiar is if we put glucose right next to this, because we did have it, okay? Oxygen, hydrogen, it was right, left, then right, and right. So now that you have this in your notebook, if you chose to write this down, we can take this information, use this as a guide to draw this now. Because remember, here's 1, 2, 3, 4, 5, and 6, way down the bottom. So then we just apply that to here. We would say 1, 2, 3, 4, okay, 5, and then 6 all the way up there. All right. So on carbon 2, that OH is to the left. So where does that place this on carbon 2? Above this or below it? Remember the clue we gave? We talked about Reader's Digest.
Or R down.
Right. R is down, but that's on the left side. So it's not going to go down, it's going to go up. So if it's on the left side, it goes up. What do we do here? On the third carbon, is it up or down? So actually on top, okay? So, and again, if you draw these hydrogen atoms in, fine. If not, then this one is up as well. Because if you were to maybe say compare this to glucose, like you probably may have in your notebook, whether this is up or down, we're not too concerned about that. This one's down, this one's up, and then this one's down. Okay, and that's what we would have noticed between these two. Okay, so on the right side it's down, on the left side it's up. On the left side it's up, this one was on the left side, so it is up. This one was on the left side, so it's up. This one's on the right side, so it's down. Remember, 1, 2, 3, 4, 5, and 6 is up here. So here we've got 1, 2, 3, 4. And you don't have to keep drawing these each and every time. It's just that now we can take this information, okay, 2, here it is. It's on the right, it's down. Here's number 3, it's on the left, so it's up. Number 4 is on the right, so it's down. There's some intermediate steps with number 5. We're not too concerned about that. We just want you to correlate that to what you see here. Because if you look at 752, where is that CH2OH? Up here on top, isn't it? And that's really where it belongs. Okay? So we have done this then too. The first thing that you're going to want to do, okay, is draw something like this. And if I'm remembering correctly, we have you memorize 3 of them. Of course, this one, glucose, that's way too important to not, because you find that sugar in almost everything, and all living organisms have glucose. Okay? Then the other one would probably be galactose, because that's on your paper. And then probably, and we can always adapt that to whatever it is that we're trying to accomplish. I would say probably ribose then. So we'll set that standard. We said you need to memorize glucose. Okay. Then We also said ribose. Okay. And then as I'm looking at this paper, we'll go ahead and say, we'll go ahead and say galactose. Okay, so those three for right now, because if you take this class next year, it's these three, and then there's about 4 or 5 more beneath that we want you to be able to draw from memory. Is that rather idiotic to do that? Well, the next person might say so, but it's all a process of separating this in your mind and being able to, let's say, take this type of data and do that. Okay. Now we want to move on to amino acids. So we're on the bus with this so far. Maybe we should ask that. Okay. Then if we're looking at amino acids, you see some of those structures on page 756. And these, if you remember from physical science, they do have a lot in common, these amino acids. They all have the same parent structure. Okay, so what would that mean to you? Well, let's go ahead and take a peek. What are we at for minute-wise? 16 and a half minutes. Okay, so regardless of any amino acid, we know that we're going to have this. Okay, so how would we know that you have these 3 bonds? Well, what type of group was this that we have learned previous to this? What organic family is that? No, because you don't have a COOH group on it. Is it an alkane, alkyne, alcohol, acid, amine? Yeah, it's an amine group because, okay, as you can see, I missed one here because it's got 3 bonds to it, okay? Just like this forms 3 bonds, okay? So what column is nitrogen in? Well, it's in the 5th column. Well, there's an electron here, 1, 2, 3. And then these 2 are unshared up there. So again, some of the concepts that you learned in physical science and in general chemistry when it comes to these electron dot diagrams, you can still use that to visualize these, but we've already accomplished that. So nitrogen with 3 bonds to it makes that an amine group. Okay? Then we have a carbon and then another carbon. So we're just going to put a couple hydrogens on here. Okay? So we have our amine side for an amino acid. How do we illustrate that this is an acid? How do we know what organic family we're looking at if it's an acid? It has COOH, which means you could do this, okay, at this level. But in the biochemistry class, we would not draw that like this, okay? And this is why, okay? Because that COOH means we still have to have 4 bonds to this. We've got 2 of them out of the way, but we have an oxygen left. And what can carbon do with oxygen to make up those last 2 bonds? If it's not a single bond, it would be a double bond. So now carbon has its 4 bonds, and that's probably the most common way that you would write that, because you can do the COOH, okay? But what happens is when you start hooking these amino acids together to make proteins, it really doesn't make any sense when you write COOH. This is just more accurate. And I think that's probably a better way of doing it, because then it's just more consistent then as you're proceeding forward. So what you see there on page 756, okay, we see cysteine there. So then what is it that we have highlighted? That's highlighted in yellow. What I don't like about it is the highlighted portion you see up top, okay? We don't put them up top, we put them on the bottom. So this is just a hydrogen atom, just like we've always done. If you don't see anything other than a stick or a dash, it's a hydrogen atom. But on the bottom, okay, how do they illustrate cysteine? On page 7, what is that, 56. Okay, so it's got another carbon atom. Okay, now remember, how many bonds does each carbon atom need to form? Okay, so there's one. And how many hydrogens do you see on with this molecule? Okay, so there's one bond, 2, 3. So it must be bonded to something down here. And it is. And I bet it's a sulfur atom. Correct? Okay, then you have to take into account, okay, what column is sulfur in on the periodic table? Same as oxygen, same as selenium. It's in the 6th column. So this same concept would go down to, or we could utilize as this, okay? Now you don't need to draw this because this is old news, okay? I'll do it how we had drawn it, okay? So we know that oxygen's in column 6. So how many bonds does this oxygen want to form to make an octet of 8? It wants to form 2 more. So you could have potassium here, and then you could have a hydrogen over here. We wouldn't say KOH, we would say that's potassium hydroxide, a really strong base. Our point is, if it's in column 6, it wants to form 2 bonds. Well, this sulfur has made 1 bond here, so where does it get that other bond that it's looking for? What does it tell you on 756? What's the sulfur bonded to besides this carbon? Bonded to a hydrogen. And we could just write it like that. Okay. So then what we want you to know for amino acids is this one. We want you to know this one, this one, this one, this one. No, the record's not stuck when it keeps going around and around, and it's not a broken record. Okay, and then this one, methionine. Okay, so what you're doing then is all of them have a very, very similar parent molecule. So then as you're looking at that, which amino acid in this group do you also see on page 756? Okay, it could be valine. I always say valine. It doesn't mean you're right or whether you're wrong. Okay, so this is an amino acid. It's glycine. If we put a methyl group on there, that's also an amino acid. It's alanine. But this says valine, which it's not just a methyl group. There's actually 2 methyl groups on there. Here's the hydrogen down here. And then we said 2 methyl groups. One on that side, one on that side. So if we look at page 756, okay, what is on either side of this carbon now, according to what you see on page 756? For valine, yep. Okay.
Another one. Yeah, like that.
Yep.
The one has a hydrogen.
Okay.
The other 2 on the outside have 3.
So we got that, and we've got that. Okay? So that is now valine. So we've learned 3 of them already because it's down here at the bottom where they all change. If nothing is here, okay, it's glycine. If there's just a methyl group, then it's alanine. Okay? Then if there's an isopropyl group down here, then it's valine. So we will pick up with this again next time. We're already up to 25 minutes, so we'll go ahead and stop there for now. And I'll just try to track down the track students. I'll hand this paper out tomorrow. So we'll catch up to you next time.